In this video, we will briefly talk about filtering data frames to select the relevant rows or elements of the data frame that we might want to work with. So we talked about conditional filtering when we talked about NumPy arrays. The idea was that often we will want to select particular parts of our data structure based on the values contained. If those values meet some condition, then we want to be able to select those parts. Since pandas, data frames, and series draw upon NumPy arrays, they inherit this conditional filtering ability. So, for example, in our Yelp data frame, among the information we have for the various businesses and the different rows is what state they're in. So there's businesses in Arizona, Wisconsin, etc. And we might be interested only in businesses in a certain location. So one thing we could do is filter the data frame based on what state a business is in. We do that by again using this dictionary-like access kind of syntax, but in fact this is really more like the syntax we used when we were filtering a NumPy array, which is not based upon dictionaries at all. So we have the name of our data frame, square brackets, just like if we were accessing a NumPy array, and then inside the square brackets we have the condition or the comparison that will control what gets returned in the output. So here we're looking for the entries where Yelp df state, where the state column of Yelp df is equal to Arizona. And we'll store the output as Arizona Yelp df. And we see in the output all the businesses contained belong in to the state Arizona, in contrast with the previous original data frame. And we can even verify that all the businesses are in Arizona by asking for the unique values in the state column of this Arizona Yelp df. And the only unique value is this Arizona. So all the businesses indeed have Arizona as their state. So how does this work? Well, again, similarly to a NumPy array, when we do a comparison between the values of some series and some particular value, we get back a series of Boolean values. So with a NumPy array, we got back a Boolean NumPy array. Here we're getting back a Boolean pandas series. And just as with NumPy arrays, this can act as a filter on the original data structure. So only rows with indices that have true values in this series will be returned if we use that Boolean series as a filter on the original data frame. We can also have multiple criteria, multiple comparisons, if we use logical operators like AND to combine those comparisons. So we can filter not only for where the state is Arizona, but also where the review count is greater than 10. And we just combine these with an ampersand for and we'll only pull out rows where both of these conditions are true. So we can see in the output here, currently, there are businesses with a review count less than 10, but if we evaluate this cell, the output of this expression is only with review counts greater than 10. So we're able to combine these two expressions, Arizona is the state value, and the review count must be greater than 10 to do a more complex filter on our data frame. The Boolean filter doesn't need to be a series. It could just be a list. So if we have true, false, true, passing that into this data frame here, we'll get the first row, we'll not have the second row, and then we'll get the third row. So rows 0 and 2. But having the filter as a series is a little more powerful in that that filter can come from any data frame or series, and as long as it shares an index with the data frame, any rows with an index matching where the true values are in our filter series will be included in our output. So let's consider just another example. If we wanted to get all the open businesses, all the businesses that still are in business, we could use that column directly to filter the data frame, because the open column is already a Boolean column. It's already a Boolean series. So we can just ask for the businesses that are open, where open is true. And that gives us all these businesses where open is true. If we wanted to get the closed businesses, we could use the not logical operator, this tilde, to negate the open column. So here we have the beginning of our open column, and if I negate it with this tilde, all those true values become false values. So now I'll get businesses that are closed, not open. And here in this output, all of the businesses have false in the open column. We can even combine these kinds of comparisons with any sort of expression, or we can use any kind of expression that returns Boolean values with this filtering ability. And one place where this gets pretty powerful is Pandas has a bunch of built-in string operations for detecting substrings or working with strings in a Pandas series. So for instance, if we wanted to check whether a string contains some substring, we could test for strings that match or contain a pattern using this string.contains method. So we're going to take the city column of the data frame and check for entries that contain Vegas, because it turns out there are businesses that are in Las Vegas, but also Las Vegas East or South Las Vegas. And if I wanted to get all of the businesses in the Las Vegas area, I wouldn't just want to check, for instance, Yelp DF city equals Las Vegas, because then I'll miss these businesses that are in Las Vegas East or South Las Vegas. If I instead check for all city strings that contain Vegas, I'll get all of those extra ones as well. So here we have in the city column businesses with Las Vegas. These are just the first 5. If I look at the unique values in the city column of our Vegas Yelp DF, the results of our filtering, then we see we get Las Vegas, North Las Vegas, There's even names here that are just a little bit poorly formatted. So we have Las Vegas with a space afterwards. And there's also North Las Vegas, N Las Vegas, N period Las Vegas. So one place where this can obviously be useful is cases where names may be incorrectly entered or where there's no standard name for some kind of object. And the name may vary depending on the source of the data. So this is a brief overview of filtering data frames. Often we will perform filtering on the way to doing some other analysis or as a way of picking out a particular subset of a larger data source that we're interested in working with.